Hello everyone, let us see the next example of orthogonal trajectories in Cartesian form. Y minus x is equal to b e raised to x. We have to find out orthogonal trajectories of this particular curve. Call that equation number 1. The first step is differential equation. Differentiate given equation with respect to x. Derivative of y is y divided by dx minus x derivative is 1 is equal to b as it is e raised to x derivative is e raised to x. Now second step is we have to eliminate the constant. So b is a constant here throughout this equation. So, with b, if e raised to x also get eliminated, then also okay, no problem. So put this value b e raised to x here in this equation, so that we get the equation number 1 becomes y minus x is equal to this divided by dx minus 1. We get b eliminate throughout this equation. B get eliminated. Now third step is replacing dy by dx is equal to minus dx by dy in particular step. We get y minus x is equal to minus dx by dy minus 1, rest of the things as it is. Now last step will be we have to solve this equation by any of the earlier method, either by exact equation, reducible exact, or linear equation, or Bernoulli, anyone. So it becomes, we have to find out in which category this equation we can solve it. Okay, so take dx by dy and multiply both sides by minus 2 to cancel minus sign. We get dx by dy plus 1 is equal to reverse the terms x minus y. Now take this is dx by dy, take this x on this side and 1 on that side. We get dx by dy minus x is equal to minus y minus 1. If you see, this is the linear equation in x and y. Instead of y, this is a reverse equation. The variables get changed only, okay, where p is nothing but minus 1 x here, and rest of the terms are functions of y only. Okay, coefficient of x is minus 1, that is p is minus 1, q is RHS side. Instead of x, we have to replace y. Instead of y, we have to replace x in linear equation. So this is the homework for you. Solve this equation, we will get this answer, okay, using linear formula or linear type. Now let us see next example. X square minus x1 minus x plus 4y is equal to 0. Call that equation number 1. Differentiate above with respect to x, we get 2x minus a plus 4 y derivative divided by dx is equal to 0. Now we have to eliminate the constant, so that calculate the constant a here. We get a, take on that side, we get a is equal to 2x plus 4 divided by dx. Now put this value in this above equation 1, we get x square minus this a value into x. This is already, this is a value here, put this value a here into this x plus 4y is equal to 0. Now take this x inside, we get x square minus 2x square minus 4x divided by dx plus 4y is equal to 0. This is the second step we have done. Now third step is replacing dy by dx is equal to minus dx by dy here. We get x square minus 2x square becomes minus x square. It's minus, this is minus x square minus 4, it becomes minus x square minus 4x dx by dy. This becomes minus plus 4x dx by dy reverse plus this 4y is equal to 0. Now to simplify this, take this x minus x square plus 4y on that side, we get 4x dx by dy is equal to, this becomes plus x square minus 4y. Now take this dy on that side, we get 4x dx is equal to, this is the thing, 4x dx is equal to x square minus 4y dy. Okay, now take this term on that side, we get 4x dx minus x square minus 4y dy is equal to 0. This is m dx plus c and dy. Reverse this term, you will get plus, or take minus with sign. This is m is equal to 4x, n is equal to, it is minus, that means 4y minus x square. Solve by any method, you will get this answer. This is the homework for you. Okay, now let us see next. X square plus y square minus 2gx, this is not 9, this is gx is equal to, g is a constant, is equal to 0. Call that equation number 1. Now differentiate, first step is differentiate with respect to x. We get x square derivative is 2x, y square derivative 2y into y derivative should be multiplied by chain rule, dy by dx. Minus 2g is a constant, x derivative is 1, is equal to 0. Now here g is a constant, so that remove this 2 on the both side, divide by 2, we get this, therefore it becomes x plus y dy by dx minus g is equal to 0. Okay, so that g becomes x plus y dy by dx. Okay, once you find constant g, put this value in this equation. That will be our third step. It becomes x square plus y square minus 2x, and this g becomes x plus y dy by dx. Just putting the value of g here only, is equal to 0. Now our last third step will be replacing the dy by dx by minus dx by dy. Before that, simplify this. X square plus it becomes x square minus 2x. Multiply this 2x inside, we get minus 2x square. The rest of the terms as it is, minus 2xy dy by dx is equal to 0. Now replacing dy by dx by minus dx by dy. X square minus 2x square becomes x minus x square plus this y square. This minus becomes this minus minus plus 2xy dx by dy is equal to 0. Now we have to simplify this equation. Therefore 2xy dx by dy is equal to, this terms take on that side, we get x square minus y square. Therefore 2xy dx is equal to x square minus y square into dy. Take this term on that side, we get 2xy minus x square minus y square dy. Take this minus inside, we get 2xy dx plus y square minus x square dy is equal to 0. Call that equation number 2. Now if you observe this, this is m, this is n, and dy by m by, we have to solve this equation. Dy by m by dy by y becomes 2x, dy by n by dy by x becomes minus 2x. This is not the exact equation. And if you see, the degree of each term is 2. There are 3 terms, 1, 2, 3. Its degree is 2, this degree is 2, this degree is 2. That means this is a homogeneous equation. For homogeneous equation, we have integrating factor as 1 upon mx plus ny. Okay, and by solving this, this is m into x plus this is n into y. We get this, solving this equation, we get this equation, and take a common y, we get x square plus y square inside the bracket. Now what we have to do, after finding integrating factor, multiply this integrating factor with this non-exact equation to become exact. Therefore multiply given equation 2 by this integrating factor, we get this equation, and which is the exact one. So that solution becomes integration of m dx, m and n are new m and n, y constant plus integration of n dy, that is term free from x. Put this value m here as it is. Take y gets cancelled, we get 2x upon x square plus y square dx plus n, terms of n which are free from x. There are no terms, there is only 2 terms or only one term, in which if you separate this term also, it contains x, because the denominator contains y plus s square. Therefore there is no any term which are free from x, therefore it will become 0 here. Okay, in this integration. Now to solve this integration, if you, this with this integration is with respect to x, y is constant, and if you observe this integration, derivative of this in denominator with respect to x is 2x. Okay, this is a constant, that's why derivative of y square is 0, and derivative of denominator is present in the numerator, that's why integration becomes log of x square plus denominator plus y square, because the formula is f dash x upon fx. Y is a constant here with respect to this integration, that's why dx is log of fx. We have used so many times. This becomes log of x square plus y square is equal to, if LHS contains all the terms as log, take constant c as log c. Okay, to cancel both the side log, we get x square plus y square is equal to c. This is the equation of orthogonal trajectories. Let us see next. Find the orthogonal trajectories of x square upon a square. This is a important one. X square upon h square plus y square upon b square plus lambda is equal to 1. We have to find out orthogonal trajectories of this equation where it contains more than one constants. A square is there, b square is there, lambda. But which constant we have to consider so that we can eliminate? It is given in the example where lambda is a parameter. That means we have to eliminate lambda only. Okay, it doesn't matter whether we are keeping a square or b square. We have to just eliminate lambda. Along with lambda, if a square and b square also eliminate, if they can eliminate, it doesn't matter. Okay, let's see how to solve it. Differentiate equation number 1 with respect to x, we get x square derivative is 2x upon a square is a constant as it is, plus y square derivative is 2y upon this is constant b square plus lambda, and y derivative should be multiplied divided by x is equal to 1 derivative is 0. Okay, now second step, before we can interchange second and third step at any example according to our comfortness. That means replacing the dy by dx and eliminating the constant. These two steps can be exchanged. Now first here replace the dy by dx as minus dx by dy. We get 2x divided by 2 on the both side, cancel out. We get x upon a square, dy by dx convert by minus dx by dy, this term y upon bx square plus lambda as it is. Okay, now we have to eliminate lambda. Okay, therefore arrange these terms to get lambda. It becomes, take this term on that side, we get y upon b square plus lambda dx by dy is equal to x upon a square. Now take except lambda, because we cannot take out b square from lambda from the denominator, so that keep as it is b square plus lambda and take every term on that side. We get x upon a square, this y comes to denominator, dy comes to numerator, dx comes to denominator. Now put this b square plus lambda value in the given equation. Okay, apart with lambda, b square also get eliminated, that doesn't matter. Okay, now put this value here. This is our second step, that is eliminating the constant. We get x square upon a square plus y square as it is. If you put this value 1 upon b square plus lambda value here, this y, this 1y gets cancelled. In the numerator it becomes only 1y, and this x upon this a square, y gets cancelled, dy by dx as it is equal to 1. Okay, now take this a square common and on that side. Now we have to just solve this equation. We get x square plus xy divided by dx is equal to a square. A square come on that side, multiply with 1, which becomes a square only. Now take x square on that side, we get xy divided by dx is equal to a square minus x square. Take dx on that side, we get y dx, y dy is equal to, take x on that side also, a square upon a square minus x square upon this x dx. If you observe, to solve this equation, if you observe dy, y terms attached to only dy, and on both the side we differentiate x terms and y terms. This is a called variable separable form. In such case we can directly integrate on both side. Okay, so integrating both side we get, because x terms and y terms again we can separate out. If we can separate out x and y terms in such a way, then it is very easy to integrate both side without solving it. So integrate both side, we get integration of y dy is equal to integration of this term dx. Separate out this a square upon x minus 1x gets cancelled, it becomes x only. dx plus integration constant, don't forget this c, plus c. Now y integration is y square by 2 is equal to a square as it is. 1 upon x integration is log x minus x integration is x square by 2 plus integration constant is c. Now let us see next. Show that orthogonal trajectories of system of confocal and coaxial parabolas is self-orthogonal. Okay. What is the meaning of that? We have to show that orthogonal trajectories of the system of confocal and coaxial parabolas. First of all, the equation of confocal and coaxial parabolas is not given in the example. We have to know what is the equation of, we have to mug up that equation of confocal and coaxial parabolas, and after finding out, after differentiating the given equation, we get one equation. Okay, and after finding its orthogonal trajectories, we have to show that the orthogonal trajectories of this system of parabolas is self-orthogonal. What do you mean by self-orthogonal? Means after differentiating the given equation and after finding out the last equation of orthogonal trajectories, those equations should be same. That means it is a self-orthogonal. Let us see how to solve this equation. Before that, we have to write down the confocal and coaxial parabolas equation. The equation of family of confocal and coaxial parabolas is given by this equation. Just write it down. This is the very important note because we have to know this equation. Okay, now first, this is the equation, call that equation number 1. Now we have to differentiate given equation with respect to x. As usual, first step, we get y square derivative is 2y dy by dx is equal to 4a is a constant, x derivative, bracket derivative should be there only 1. A is a constant, a derivative is 0. Okay, now from this equation we have to find out a. We get a is equal to y upon 2, 4 take on this side, y upon 2 dy by dx. Now put this value in the given equation. Equation number 1 becomes y square is equal to 4ax, multiply this 4a inside, we get 4ax plus 4a square. Now put this value of a here and here also, we get 4x, a value is this, plus 4a square is this bracket square. Okay, now simplify. Y square is equal to 2 gets cancelled, 2xy dy by dx plus this again 4 gets cancelled because 2 square is 4, 4 gets cancelled, and this becomes y square dy by dx bracket square. Okay, now it becomes y. Now if you observe this equation, y everywhere y terms are there, therefore divide both equation, both the side by y, or cancel out the 1y, we get y is equal to 2x dy by dx plus 1y dy by dx bracket square. Okay, this is the one differential equation after eliminating the constant of this equation. Okay, call that equation number 2. Now what we have to do? We have to find out the orthogonal trajectories of this differential equation. Means the fourth step or third step is very important, the replacing step, where we replace dy by dx as minus dx by dy, so reverse. At that step we are changing the given equation. Okay, at that step we have to show that after changing dy by dx is equal to minus dx by dy, whatever we are getting the equation of orthogonal trajectories of this confocal and coaxial parabolas, that equation and this equation must be same. Okay, let us see. Now next step is differentiating, replacing dy by dx as minus dx by dy. that is equal to we are for that, for only calculation purpose, dx by dy we are written we are write it as minus 1 upon reverse of dy by dx, right? This dx comes to numerator as it is, it becomes equal. Now put this value as dy by dx here in this earlier example. We get y is equal to, in this equation, it becomes y is equal to minus dy by dx replaced by minus 1 upon dy by dx. It becomes minus 2x 1 upon dy by dx plus y, and it is dy by dx bracket square. Its square is minus square is plus 1 upon its bracket square. Okay. Now let us see whether that equation and this equation is same or not. Now multiplying the highest power of dy by dx by both sides, we get y dy by dx bracket square is equal to minus 2x, 1 dy by dx gets cancelled, we get 1 dy by dx plus only y. Now take this term on that side, we get y is equal to, this becomes plus 2x dy by dx plus y into dy by dx bracket square. This is the orthogonal trajectories of the given equation. Call that equation number 3. And if you observe this equation and our earlier equation, this 2 number equation and 3 number equation is same. Okay, equation 2 and equation 3 are same. That means the given parabola set of family of set of parabola, confocal and coaxial parabolas equation, we have already written in the equation number 1. These are self orthogonal. Okay, after replacing also they are not changing their property, that's why they are called self orthogonal. Okay, now we have seen the orthogonal trajectories of Cartesian form. Now we are going to see orthogonal trajectories in the polar form. That means polar form means where instead of xy there is r and theta. Therefore there is a slight change in steps of finding out the orthogonal trajectories. There is only one step which is different from the Cartesian form. The first step is, as usual, differentiate given equation. Instead of y there is r, instead of x there is theta. Okay, just correlate these two theories. Differentiate the given equation with respect to that. In Cartesian we have differentiate the given equation with respect to x. Now in this equation, in this polar form, we have to differentiate given equation with respect to theta to get dr by d theta. There we get dy by dx. Here we are getting dr by d theta. First step is same. Second step is also same, eliminating the constant as usual. The third step is only the different, having the difference than Cartesian form. Replacing, we in Cartesian form we replace dy by dx as minus the reverse dx by dy. In this example, in this polar form, we are replacing dr by d theta by is equal to, just only one term gets extra attached to this d theta by dr, that is minus r square d theta by dr. It is only r square difference is there. Okay, now after that we have to solve the given equation as usual. Okay, now let us see the example. Find the orthogonal trajectories of the question is find orthogonal trajectory of the cardioid. Cardioid means this is the name of this equation or name of this curve. It doesn't matter whether it is given or not. Equation, we want only equation. R is equal to a into bracket 1 minus cos theta. We have already seen this equation in tracing of curve in M1. Okay, it doesn't matter. Now let us see how to find out orthogonal trajectories of this Cartesian. If you see this equation, it contains r and theta. That means it is a polar form. That means we have to follow these steps. Okay, let us start with the first step. Call this equation number 1. Now differentiate given equation with respect to theta. we get r derivative is dr by d theta. A is a constant, bracket derivative 1 derivative is 0, cos derivative is minus sign, minus minus becomes plus sign theta. Therefore we have to, now this is the first step. Second step, eliminating the constant, so that a becomes 1 upon sine theta dr by d theta. Put this value in the given equation, we get r is equal to, a value is this, and 1 minus cos theta as it is. Okay, now this is the second step. Third step is replacing dr by d theta is equal to minus r square d theta upon dr in this equation. We get r is equal to 1 minus cos theta upon sin theta, and as it is, and dr by d theta replaced by minus r square d theta upon dr. This third step. Now last step is we have to just solve this as usual. Just instead of x and y, they have only r and theta variables. Now let us see. 1 r gets cancelled from the both side. Okay, now take this r on that side, we get 1 upon r, and dr on that side, we get dr. This minus as it is, okay, and d theta as it is, and this term as it is. Okay, on one side we are getting r, on other side we are getting totally theta. That's why this is a variable separable form. We can easily integrate both side. Now integrating both side, we get 1 integration of 1 upon r dr is equal to minus as it is, integration of 1 minus cos theta upon sin theta d theta plus integration constant c. Now here we have to use trigonometry and integration formula. 1 upon x integration is log x, therefore integration of 1 upon r is log r is equal to minus 1 upon sin theta, just separate out this, 1 upon sin theta minus cos upon sin is cot d theta plus c. Now again we know take this minus inside, cot theta becomes first, minus 1 upon sin is cosec theta d theta is equal to plus c integration constant. Now cot theta integration is log of sin theta, this is the formula, and cosec theta integration is minus as it is log of cosec x minus cot x plus c as it is. Okay, now everywhere in every term log is there. Now take use this formula, log a minus log b is equal to log a upon b. Therefore it becomes log of sin theta upon this cosec minus cot, plus everywhere log is there, that's why take c as a log c. Okay, therefore r is equal to, now log a plus log b is again, we are using this log a into b. Okay, therefore it becomes c into this sin theta upon cosec theta minus cot theta, and from the both side log gets cancelled. Therefore r is equal to c into this term. This is the orthogonal trajectories of the given equation. Now let us see next equation in the polar form. R is equal to 2a upon 1 plus cos 2 theta. Now if this is the other method to find out the derivative after differentiating, what we want to eliminate the constant, we want that second step. That's why it is, if numerical if the given equation is given in the numerator denominator form, then it is very easy to take log on both side. Once we take log on both side, the differentiation becomes very easy. Okay, let us see how it will be. Take log on both side, we get log of r. In earlier example there is no numerical denominator form, that's why we directly differentiate. Now in this case, if numerator and denominator form is there, and after that we have to take the derivative, before that take the log on both side, so that it becomes very easy. Take log on both side, we get log r is equal to log a upon b, that is log of 2a upon 1 plus cos theta is log a plus minus, it becomes minus. So it becomes log a upon b is log a minus log b. By that we get log 2a minus log of this 1 plus cos 2 theta. Now differentiate both the side with respect to theta. What we get? Log r derivative is 1 by r derivative is dr by d theta is equal to 2a is a constant and log of constant is again a constant, that's why its derivative is 0. That's why we are taking the log on both sides in first step only, because after taking the derivative our third step automatically we are eliminating the constant. In both the step we are getting in one step only. Okay, this is the benefit of log, taking log before differentiating the equation. Now it becomes minus log derivative is log x derivative is 1 upon x, that is 1 upon 1 plus cos 2 theta, into we have to multiply this derivative. Its derivative is, it becomes minus, already is minus there, and cos derivative is already minus, one derivative is 0, cos derivative is minus sine 2 theta into 2, it becomes minus minus plus. Okay, 2 sine 2 theta. Now third step already eliminating constant, differentiating, and now third step will be replacing the dr by d theta is equal to minus r square d theta by dr. It becomes minus r square upon this r as it is, d theta by dr is equal to this step as it is, 2 sine 2 theta upon 1 plus cos 2 theta. Now one r gets cancelled, it becomes, take minus on that side, or it becomes minus r, one r get cancelled, d theta upon dr is equal to minus 2 sine theta, sine 2 theta upon 1 plus cos 2 theta. Okay, now last step is we have to solve this equation. So take theta on one side, on r and other side. For that take dr on that side, r on that side, keep the 2 minus 2 as it is constant there, and theta on terms on this side, sine 2 theta on the denominator. It becomes minus 2 upon r dr is equal to 1 plus cos 2 theta upon sine 2 theta d theta. If you observe, r terms are on that side, theta terms are on that side, one side of the equation. That's why integrating both sides, we can integrate both sides easily. We get minus 2 is a constant, integration of 1 upon r dr is equal to integration of this term d theta plus c. Okay, log 1 upon r derivative is log r minus 2 constant as it is, and we know one formula. We have to use trigonometry here to solve this integration. 1 plus cos 2 theta is 2 cos square theta, and sine 2 theta is 2 sine theta cos theta. These are two well-known formulae. Put these values in the here. It becomes 2 cos square theta here, and in the denominator it becomes 2 sine theta cos theta. Okay, now 2 gets cancelled, 1 cos gets cancelled, integration of 1 cos upon sine, that is cot, and integration of cot is log of sine theta, plus everywhere is log, again take this minus 2 on the indice, because log m raised to n is n log m, right? This n can be come into indice, that's why this minus 2 come to r raised to minus 2, and log of sine theta plus take c as a log c, because every term is log. Log a plus log b is log a into b, and cancel out this log on both sides, we get r raised to minus 2 is equal to c sine theta, or 1 upon r square is equal to c sine theta.